Bismillahir Rahmanir Rahim. Hello students, this is Hamza Noor from Aero Education Network, and today I'm going to solve some questions from International A-Level Edexcel M1 Mechanics. The topic is constant acceleration, kinematics. Okay, and we have a past paper handout over here. First of all, we have question number one of the handout, which is GCE M1 June 2010, question number 5. Alright, so let's see what the question says. Two cars P and Q are moving in the same direction along the same straight horizontal road. Car P is moving with constant speed of 25. Okay. At time t is equal to 0, P overtakes Q. Okay, car P overtakes car Q, which is moving with constant speed of 20. As we can see that car P is moving with a constant speed of 25 meter per second. Okay. And car Q is basically moving with a constant speed of 20 meter per second. Okay. And at time t is equal to 0, car P overtakes Q, which means that the journey is starting from the point where car P overtakes car Q. Okay. Car Q is moving with a constant speed of 20 and P overtakes it. And since the point of overtaking, our journey starts. All right. And then it says that from t is equals to capital T seconds, car P decelerates uniformly, coming to rest at a point X, which is 800 meters from the point where P overtook Q. Okay, so from T is equals to uppercase alphabet T, car P basically decelerates uniformly, which means constantly, coming to rest at a point X. Okay, so this means that point X is 800 meter away from the point where P overtook Q. Okay, so if we make the graph of only car P, so the area under the speed time graph will be the distance. Okay, and this will be 800 meter. This distance will be 800 meter. And from t is equals to 25 seconds, Q decelerates uniformly, coming to rest at the same point X at the same instant as P. Okay, so from t is equals to 25 seconds, okay, the speed of car Q decreases constantly, coming to rest at the same point X, which is 800 meter away from the point of overtaking and at the same instant as car P. This means that both cars have covered the same distance since car P overtook Q. And our journey is basically starting from the point t is equal to 0. Obviously, our journey is starting from the point where car P overtakes car Q. Okay. So this is basically the whole story going on over here, the whole scenario. So the requirement of part A is to sketch on the same axis the speed time graphs of the two cars for the period from t is equal to 0 to the time when they both come to rest at the point X. Okay, so we are going to sketch a speed time graph over here. Okay, so first we make the horizontal axis, t seconds. This is the origin, and this is the vertical axis. So this is v meter per second, or you can simply say speed as well. You can mention speed as well over here because this is a speed time graph. Okay, so basically what happens is that car P is moving with a constant speed of 25 meter per second. Okay, so first of all, I'm going to make a horizontal line over here. Okay, for car P, the speed is 25 meter per second. And for car P, what happens is that from t is equals to uppercase alphabet t seconds, speed decelerates uniformly, coming to rest at a point x, which is 800 meter from the point where p overtook q. So when t is equals to uppercase alphabet t, basically the speed of the car starts to get reduced constantly, and it comes to rest at a point x, which is 800 meter away from the initial point. The initial point was where P overtook Q. So here we have a downward sloping line, and this is the journey for car P. Okay, this is the journey for car P. And at which time it comes to rest, we don't know that point. So let's keep it a small alphabet t, a small t over here. Okay, so this is basically the sketch for car P. And then we have car Q, which is moving with a constant speed of 20 meter per second. 20 meter per second. Obviously, this speed is less than 25, and it basically moves with constant speed, 20 meter per second. But from t is equals to 25 seconds, the speed of car Q decreases constantly, coming to rest at the same point x at the same instant as p. So basically, car Q starts to decelerate from t is equals to 25 seconds. Okay. So first of all, car Q is moving with a constant speed of 20 meter per second. So I'm going to make a horizontal line over here like this. Okay. And from t is equals to 25, it starts to decelerate. Okay. And it comes to rest at the same instant, at the same point x, at the same instant as car P. Okay, so from t is equals to 25 seconds to t is equals to small t, we will have a downward sloping line over here. And this is basically the journey of car Q. Here I'm going to write car Q. So now the question arises that why have I made the sketch for car Q in this particular way, particularly in this way? And why have I not made the sketch for this car Q something like this? Okay, so first thing is that there should be a point of intersection between the two graphs where we don't know the value of t. Okay, and at this point, speeds for both cars would be the same because car P is initially moving with a speed higher than car Q. So obviously, when at time t is equals to capital T, car P starts to decrease the speed. So obviously it has to reach a speed of 20 as well. And car Q is already moving with a speed of 20. Okay, so there should be a point of intersection between these two graphs. Okay, and one more thing, why we can say that this value of capital T is basically less than 25, meaning why should we say that this 25 is higher than this capital T? Meaning if you would have made a sketch something like this for car Q where this point was T is equals to 25, so it would be impossible. Okay, why? Because car P is overtaking car Q. Car P is moving with speed 25, car Q is moving with speed Q, and obviously they have to reach at the same instant at point X and the same point X. And point X is basically 800 meter away from the point of overtaking. Okay, so when car P is moving with a constant speed of 25 at a time t is equals to t seconds, uppercase alphabet t second, it starts to reduce its speed and eventually meets the speed of car Q, and then it comes to rest. Okay, so obviously car P has to start its journey of deceleration before the time car Q starts its journey of deceleration, because it has to come to rest at the same instant as car Q. Both cars have to come at rest at the same instant and at the same point. Okay, in any other case, this whole scenario would have not been possible. Okay, and since both cars are coming at rest at the same point at the same instant, so the distance covered by both of the cars should be equal. Okay, both should be 800 meter. both distances covered by both of the cars should be 800 meter, meaning areas of both of these trapeziums should be equal to each other. All right. So this is basically the whole concept behind this. This was the requirement of part A. All right. So now let's move on to part B. We need to find the value of t, uppercase alphabet T. Okay, and area of both of these trapeziums will be equal. So first of all, let's find this value of a small t. Okay, and by this we would be able to find the value of uppercase alphabet T. Okay, so first of all, for car Q, if I consider the journey of car Q, so area of trapezium is obviously equal to 800 because the distance covered by both cars is the same. Okay, so I can say that 800 is equals to area of trapezium half into height into sum of parallel sides. So if you consider the graph of car Q, okay, so height is basically 20 over here because height is the perpendicular distance between the two parallel sides. So the height of the trapezium for car Q is 20 and one parallel side for car Q is 25 and the other parallel side is T. Okay, so one parallel side is 25 and the other parallel side is a small t. So just solve this equation and obtain the value of a small t. So 800 multiplied by 2 divided by 20 is equals to 25 plus t. Okay, so just calculate this value. So 800 multiplied by 2 divided by 20, this is supposed to be 80. Okay, so this means 25 plus t is equals to 80, and therefore the value of a small t is 80 minus 25, which is 55 seconds. Okay, the value of a small t is 55 seconds, and now we need to find the value of uppercase alphabet T, and for that purpose, we are going to consider the journey for car P. Okay, so car P has also covered the same distance, 800, but for car P, the area of trapezium will be found in this way, that the height of the trapezium is 25 and one parallel side is T, the uppercase alphabet T, and the other parallel side is a small t, meaning 55, which we have obtained. Okay, so 800 is equals to half multiplied by 25 multiplied by t plus 55. So 800 multiplied by 2 divided by 25, this will be equals to t plus 55. So 800 multiplied by 2 divided by 25, this is 64. So 64 is equals to t plus 55, and therefore the value of t is 64 minus 55, meaning t is equals to 9 seconds. This is supposed to be your answer. And as you can see that this value of uppercase alphabet T is less than 25. Okay, so this makes sense. So this was basically the working for part B. Okay, so this was basically the question number 1 of the handout, GCE M1 June 2010, question number 5. So now let's move on to the next question. All right, so now let's move on to question number 2. This is June 2010, GCE M1, question number 6. Okay, this is the same paper, question number 6. It says that a ball is projected vertically upwards with a speed of 14.7 meter per second from a point which is 49 meter above horizontal ground. Modeling the ball as a particle moving freely under gravity, find the greatest height above the ground reached by the ball. All right, so first thing first, I'm going to make a sketch over here. Let's say here we have the horizontal ground and the ball is projected vertically upwards with a speed of 14.7 meter per second. Okay, and the point is basically 49 meter above the horizontal ground. Okay, and we need to find the greatest height the ball has reached above the ground. Okay, so at the greatest height, the velocity will be equal to 0, because after this the ball will change the path of its motion and it will start to come towards ground. So after this point, velocity will become negative. When the ball will change the path of its motion, velocity will become negative. Okay, when the ball is going upwards, velocity will be positive. It will reach a maximum height where the ball will be instantaneously at rest, after which it will change the path of its motion. So when the ball is going upwards, it is decelerating, meaning it is slowing down. And when the ball is coming back, it is accelerating in the opposite direction. So this means that in this overall journey, the acceleration will be taken as negative. Okay, which means that when the ball is going up, it is decelerating, and when the ball is coming down, it is accelerating in the opposite path. So in this case, in part A, we need to find the greatest height. So I will keep V is equal to 0 and find the displacement over here. Okay, I will find how much displacement the ball has covered, which will tell us basically the distance, because up till V is equal to 0, the ball has not changed the path of motion. So distance and displacement will remain same. So V is equal to 0. U is 14.7. Acceleration will be taken as minus G, which is minus 9.8. Okay, this is basically the acceleration due to gravity. Okay, and we need to find the value of S. So V square is equals to U square plus 2AS. So in place of V, we are going to write 0. And in place of U, 14.7. And acceleration is minus 9.8. So solve this equation and find the value of S. So 19.6 times S is equals to 14.7 square, meaning 216.09. So therefore S is equals to 216.09 divided by 19.6. How much this is? This is 11.025 meter. But we need to find the height above the ground. So obviously we need to add this initial distance 49 meter, because ball was released from the point 49 meter above the ground. Okay, so the height above the ground, therefore the height above the ground is 49 plus 11.025. Okay, so 49 plus 11.025. This is supposed to be how much? This is 60.025. Okay, so in M1, either you can give your final answers correct to two significant figures or three significant figures. Okay, so first I write the value to a higher degree of accuracy, which is 60.025, and then correct to three significant figures. This is 60.0 meter. This is supposed to be your answer. In M1, you can give your answers correct to 3SF or 2SF as well. The non-exact values, okay, the value which you are obtaining over here, 60.025, this is a non-exact value because acceleration is an approximate value over here, which is according to the Edexcel M1 syllabus, this is minus 9.8. This is an approximate value. So obviously this distance is also an approximate value, not an exact value of the distance. So I've mentioned my answer correct to 3SF over here. Otherwise, you can give correct to 2SF as well in mechanics M1. And then part B, then we have part B, which says that we need to find the speed with which the ball first strikes the ground. Okay, so first of all, what we are going to do, we are going to find the velocity. Okay, so we need to find the speed with which ball first strikes the ground. Here I'm going to find the velocity over here. Okay, so if I start my journey from t is equal to 0 over here, and then when I'm coming on the ground, when the ball is striking the ground, So obviously, as we can see that when v is equal to 0, we have found that this height is 11.025, and we have also found the greatest height above the ground. So what we can do, when we start from t is equal to 0 and we end at this point when ball strikes the ground, so displacement will be what? Displacement will be taken as minus 49 meter. Okay, because ball is changing the path of motion. So let's say this is point A, this is point B, and point C. So if I am considering this journey from point A to point B to point C, so from point A, t is equal to 0. At point A, t is equal to 0. My journey has started. So displacement will be, first of all, the value of s which you found over here, that is 11.025 meter. And then you subtract this complete height which you found in part A. So from 11.025 meter, you are subtracting 60.025 meter. Okay, so obviously this will be minus 49 meter, because when the ball has come on the point C, the ball when it strikes the ground, so displacement is minus 49 meter, meaning it is in the opposite path. Okay, and it is 49 meter away from the starting point, but in the opposite path. Okay, so at point C, I can say that the displacement is minus 49 meter. So at this point, I'm going to find the velocity. Okay, and obviously, whatever the value of velocity will come, it will come as a negative value because ball has changed the path of motion. Okay, so V is unknown. U is 14.7 meter, 14.7 meter per second. Okay, and acceleration is obviously due to gravity. Okay, in this whole journey, we are going to take the negative value of acceleration, because when the ball is going upwards, it is decelerating, meaning it is slowing down. And when the ball is coming downwards, it is accelerating in the opposite path. Okay, so when the ball is going upwards, it is decelerating, and when the ball is coming down towards the ground, it is accelerating in the opposite path. So obviously, we will have a negative value of acceleration for this whole journey. Okay, so this is basically the concept behind this. All right, so I'm going to say that v square is equals to u square plus 2as. Okay, so v square is equals to 14.7 square plus 2 times minus 9.8 times minus 49. So what is the value of v square? 14.7 square plus 2 times minus 9.8 times minus 49. So v square is 1176.49. V square is 1176.49, and v is equals to plus minus under root of this 1176.49. Obviously, the value of velocity will be a negative value. Okay, so this is 34.3. So velocity is minus 34.3. But we are required to find the speed. So therefore, the speed is 34.3 meter per second. Therefore, the requirement, which is speed, is 34.3 meter per second. Why have I taken the negative value of velocity? Because particle has changed the direction of motion. It is coming now backwards. Okay, so you need to be familiar with all of these concepts before attempting past paper questions. Okay, so this was complete part A and this was part B. Alternatively, what you can do is, for part B, you can only consider this journey from point B to point C. If you only consider this B to C journey, so U will be taken as 0 and V will be unknown. V will come as a positive value. And since we would be only considering this journey where ball is coming towards the ground, okay, so it is accelerating, so we will take the positive value for acceleration. Okay, and we will get the same answer. So I'm doing an alternative working for part B. I'm doing an alternative working for part B, in which I consider the journey from point B to point C, B and C, as I have mentioned on my sketch. Okay, so in this particular method, u will be taken as 0. Okay, because at the highest point above the ground, the velocity was 0. And when particle comes to point C, so the speed is unknown, so velocity is unknown. Acceleration will be taken as a positive value because we are considering only the downward journey of the ball. So it is speeding up. So we will take positive value for acceleration, and the displacement we will take as this complete height above the ground, which we found in part A, which was basically this 49 meter plus the distance you found over here, 11.025. So this was 60.025. So I will take the displacement, the highest, uh, the height which is above the ground. Okay, I'm going to use this complete value which I found over here. And now you will solve the equation. Okay, you are going to use v square is equals to u square plus 2as, and when you solve the equation you will obtain a positive value of v, because we are only considering the journey where the ball is coming downwards. Okay, so v square is equals to u square plus 2as, meaning v square is equals to, in place of u you are going to write 0, and then plus 2 times acceleration times displacement. Displacement is 60.025. Okay, so if you put this thing in your calculator complete, so what is the value? The same value of v square. Okay, v square is equals to 1176.49, but when you take the square root, okay, so conceptually you get two values. Okay, but you will choose the positive value over here because we are only considering the downward journey of the ball. So when you are considering the downward journey of the ball only, so ball is not changing the path of motion. Okay, so velocity is 34.3, and therefore you are going to say that speed is 34.3 meter per second. Okay, so this was basically an alternative approach for part B. So now coming on to part C, I'll bring the picture of the question on the next page. So in part C, it is required to find the total time from when the ball is projected to when it first strikes the ground. Okay, so uh, the approach which we used earlier in part B. So I've taken the whole journey where the displacement was minus 49 meter. So I just need to find the value of t now. Okay, so if I consider the information, if I first bring the sketch on the next page, this would be more comfortable. Okay. I'll bring the picture of this sketch which I made on the next page. So I need to find the total time when the ball is projected to when it first strikes the ground, meaning I'm considering this complete journey from point A to point B to point C. So displacement is obviously minus 49 meter. Okay, and when you are considering the complete journey from A to B to C, so acceleration will be taken as a negative value, minus 9.8. Okay, and what we know, the matter of fact that the velocity when ball reached this point C, velocity was minus 34.3. Okay, the velocity was minus 34.3. All of these quantities are vector quantities except for t. T is basically time, so time is a scalar quantity. All other quantities V, U, A, and S, these are vector quantities. So velocity was minus 34.3, okay? This is the thing. And the initial velocity was 14.7. So whichever equation feels comfortable to you, use that equation. So you just need to find the value of T. So I can use V is equals to U plus AT. All right. So V is minus 34.3. Okay. Because ball has changed the direction of motion when it is coming downwards. So minus 34.3 is equals to 14.7 plus acceleration times T, and acceleration is minus 9.8. So just solve this linear equation in terms of T and find the value of T. Okay. So 14.7 plus 34.3, how much this is? 14.7 plus 34.3, this is 49. So T is equals to 49 divided by 9.8. So this is 5 seconds. T is equals to 5 seconds. This is supposed to be your answer. All right. Alternatively, what you can do, you can uh, use this equation as well. S is equals to ut plus half at square. So in which displacement is minus 49. So minus 49 is equals to 14.7 t plus half times minus 9.8 times t square. So you just solve the quadratic equation in terms of t and choose the positive value of t over here. So minus 49 is equals to 14.7 t minus 4.9 t square. Okay, so 4.9 t square minus 14.7 t minus 49 is equal to 0. So just use the quadratic formula. T is equals to minus b plus minus under root of b square minus 4ac completely divided by 2 times a. Okay, and just find the values. So t is equals to 14.7 plus minus what? B square minus 4ac. What is this? Just put this thing in your calculator. So under root of this value is 34.3. So 14.7 plus minus 34.3 divided by 2 times 4.9. So obviously t will have a positive value. So the positive value of t will be 14.7 plus 34.3 divided by 9.8. So first we have a positive value, which is t is equals to 5, and the other one is going to be a negative value, which will be rejected since time is not less than 0. Since time cannot be negative, that's why. So t is equals to minus 2 will be rejected. And therefore, the only acceptable value is t is equals to 5. Okay, but the earlier approach was much quicker, much effective. So I've used the first method, but I have also explained in this alternative approach as well. So this was basically an alternative approach for part C. Alright, so in this video, I've discussed these two questions only, and inshallah I'll be uploading more videos. So this question was question number 2 of the handout, which is June 2010, question number 6. And the earlier question was question number 1, which was from the same paper, June 2010, question number 5. These both questions are from GCE M1 paper. All right. So inshallah, I'll be uploading more videos soon. So stay tuned to my channel and thanks for watching. Assalamu alaikum.